This is a video walkthrough for practice 6A. In our first two questions, we're asked to respond using complete sentences. Number 1, why does the simplification of the square root of x squared require absolute value, while the simplification of the cube root of x cubed should not use absolute value? And that is because, regardless of whether x is a positive number or a negative number, x squared is positive, and the square root of a positive number is another positive number. When x is positive, x cubed is also positive, and when x is negative, x cubed is also negative. The cube root of a positive number is another positive number, and the cube root of a negative is another negative number. So, when we take the cube root of a cube, the sign is preserved, and when we take the square root of a square, the sign will always be positive, so absolute value is necessary. In number 2, we are asked why the square root of x to the 16th is x to the 8th rather than x to the 4th power. It seems like we should just be able to take the square root of 16 and the result should be 4. However, exponents need to be treated differently. It is important to realize that the square root of x to the 16th represents the expression that when multiplied by itself produces x to the 16th. And x to the 8th times x to the 8th is equal to x to the 16th. While x to the 4th times x to the 4th power is x to the 8th. Okay, in 3 through 32, we're asked to simplify each numeric expression or indicate that it is not a real number. In number 3, we see a negative, but it's outside the radical. So that just means that the result is going to be negative. And we can distribute that square root to the numerator and denominator. And then we have the square root of 25 divided by the square root of 49. So that's going to give us a final result of negative 5/7. We can do this a similar process for a cube root. The cube root of 1/8 is the cube root of 1 divided by the cube root of 8, and that would be 1/2 or 1/2. In number 5, we have the square root of a decimal. It will be easiest for us if we express this decimal in fraction form. So let's take a look at our place values. First place value past the decimal point is tenths, hundredths, thousandths, and then 10,000ths. So what we really have is the square root of 49 10,000ths, and that is the square root of 49 divided by the square root of 10,000, and that would be 7/100, which, if we re-express that in decimal form, is 0.07. Either one of those two answers are fine. All right, let's do something similar with number 6. This can be re-expressed in fraction form as the cube root of 27/1000. And that will be equal to the cube root of 27 divided by the cube root of 1000. And that will be equal to 3 divided by 10. In number 7, we have the square root of negative 9. That's the square root of a negative number. An even root of a negative number is not real. Later, we're going to re-express that and give an imaginary result for that. But for now, all we're going to say is not real. In number 8, to contrast, the cube root of a negative number is another negative number. And the cube root of negative 1 is negative 1. And if you're thinking about why that is true, that's because negative 1 times negative 1 times negative 1, or negative 1 cubed, is equal to negative 1. But negative 1 is our final answer there. The cube root of 0 is the number that, when multiplied by itself, and then by itself again, gives a result of 0, so the cube root of 0 has to be 0. In number 10, we have an even root, and the negative's on the outside of the radical, so we evaluate the radical first and just bring the negative along with us. So the fourth root of 16 is 2, so the result is negative 2. And remember that a fourth root of 16 is the number that, when multiplied by itself, gives us 16, and multiplied by itself, 4 factors, gives us a result of 16. In number 11, we have an even root of a negative number. That's not real because an even number of factors, when multiplied together, will never give you a negative result. In number 12, we have an odd root of a negative number. That's going to be another negative number, and that gives us a result of negative 2. And let's think about why. The reason why is that negative 2 times negative 2 times negative 2 times negative 2 is equal to negative 32. For number 13, the fourth root of 81 is 3. That's because 3 times 3 times 3 times 3 is equal to 81. In number 14, the cube root of 343 is 7. That's on our memory list because 7 cubed, or 7 times 7 times 7, is 343. In number 15, we're asked to simplify the square root of 48. So we are going to think about our perfect square numbers. Our perfect square numbers are 1, 4, 9, 16, etc. The largest perfect square number that divides evenly into 48 is 16. So we can re-express this as the square root of 16 times the square root of 3, because 16 times 3 is 48, and that will give us 4 times the square root of 3 as a final result. In 16, we need to simplify by identifying perfect cube factors. Perfect cube factors are 1, 8, 27, 64, 125, and sure enough, 125 divides evenly into 250. So this can be re-expressed as the cube root of 125 times the cube root of 2. So that's 5 times the cube root of 2. Make sure that you're putting the index of the radical, that's the 3, in that crook of the radical so that it's not confused with the coefficient, which is 5. In number 17, we have a perfect cube factor of 1000. And so we can re-express this as the cube root of 1000 times the cube root of 7. The cube root of 1000 is 10, so this is 10 times the cube root of 7. In 18, we're looking for our perfect fourth powers. Perfect fourth powers are 1 to the fourth is 1, 2 to the fourth is 16. Ding, 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 ding. That's our perfect fourth power factor, and so this can be re-expressed as the fourth root of 16 times the fourth root of 10. The fourth root of 16 is 2, so this is 2 times the fourth root of 10. And of course 10 does have other prime factors, 5 and 2, but neither is a perfect fourth power, so we are done simplifying. In number 19, we have the cube root of 32. We are looking for our perfect cube factors, and the cube root of 8 is one of the factors of the cube root of 32. So the cube root of 8 times the cube root of 4 gives us 2 times the cube root of 4. In number 20, we have the cube root of negative 7. Now, to be in simplest form, a radical should never contain a negative number. This is a real number, so it just needs to be simplified by factoring out the cube root of negative 1. So this is the cube root of negative 1 times the cube root of 7, which is negative 1 times the cube root of 7. And of course, we don't need a coefficient of 1, so we'll just express it as negative cube root of 7. In 21, we're looking for a perfect cube factor, and in fact, we can factor out that cube root of a negative first. So we can factor this into the cube root of negative 27 times the cube root of 2, and that will give us negative 3 times the cube root of 2. In 22, the fourth root of 1 is 1, because 1 times 1 times 1 times 1 is 1. In number 23, the fourth root of 162, we can factor a perfect fourth power of 81. So this is the fourth root of 81 times the fourth root of 2. The fourth root of 81 is 3, so now we have 3 times the fourth root of 2. In 24, we have the cube root of 216. This is 6 because 6 times 6 times 6, or 6 cubed, is 216. In number 25, we have the third root of 686. Now 343 is a perfect cube factor. It's 7 cubed. So we can factor that out. The cube root of 343 times the cube root of 2. So that will give us 7 times the cube root of 2. In 26, the square root of 54. So we're looking for perfect square factors. Perfect square factors are 1, 4, 9, 16, 25, etc. 9, I believe, is the biggest factor in that list that divides evenly into 54. So 9 times 6 is 54. So we have the square root of 9 times the square root of 6, giving us 3 times the square root of 6. In 27, we have 5 times the cube root of 64. So this is 5 times the cube root of 64, which is a whole number, 4, and 5 times 4 is 20. In 28, we have 6 times the square root of 75. So 6 times, and we'll simplify the square root of 75 since it's not a whole number. Perfect square factor that divides evenly into 75 is 25. So the square root of 75 is the square root of 25 times the square root of 3. This gives us 6 times 5 times the square root of 3, or 30 times the square root of 3. In 29, 13 times the cube root of 40. So we have 13 times, and we're looking for a perfect cube factor. Remember, our perfect cube factors are 1, 8, 27, 64, etc. 8 is the largest number that divides evenly into 40. So this is 13 times the cube root of 8 times the cube root of 5. And the cube root of 8 is 2. So this gives us a final result of 26 times the cube root of 5. In 30, square root of 5 times the square root of 5, we can use the product rule to re-express this as the square root of 25, and that's 5. The cube root of 2 times the cube root of 2 is the cube root of 4, and remember, we're not finding a square root, so the cube root of 4 doesn't actually simplify. That's as far as that's going to go. Now in 32, we have the cube root of 2 times the cube root of 2 times the cube root of 2. So that would be the cube root of 2 times 2 times 2, which is the cube root of 8, which is 2. In number 33, the square root of 2 divided by 169 is the square root of 2 divided by the square root of 169, and that's the square root of 2 divided by 13. In number 34, what we can do here is, if you want, factor that numerator. The numerator can be factored into the square root of 3, because that's a factor in the denominator, times the square root of 5, and then divided by the square root of 3. And we can cancel those common factors of the square root of 3 in the numerator and denominator to simplify, and that just gives us the square root of 5. Alternately, you could make this the square root of 15 over 3, and that would be the square root of 5. Same result either way. In number 35, we can factor again. That's the cube root of 3 times the cube root of 8 divided by the cube root of 3. Cancel those common factors in the numerator and denominator, and the cube root of 8 simplifies to 2. Okay, in 36 through 53, we are simplifying expressions that involve variables. Now we're going to assume that all variables represent positive numbers, so we're not going to use absolute value. It's not necessary. In 36, the square root of a to the 8th is a to the 4th power. And if you're thinking about why is that true, that's because a to the 4th times a to the 4th is a to the 8th. We're not taking the square root of 8, we are taking the square root of a to the 8th power. And if you're thinking about maybe using a shortcut when we're working with exponents on variables, the index of the radical divides into the exponent. So 2 divides into 8, and we get a new exponent of 4. We can use that same idea here. The third root of m to the 21st is m to the 7th power. again, the index of the radical divides into that exponent. But if you're thinking about y, that would be because m to the 7th times m to the 7th times m to the 7th is m to the 21st power. In 38, the 4th root of u to the 20th power would be u to the 5th, because u to the 5th times u to the 5th times u to the 5th times u to the 5th is u to the 20th power. Or, again, divide that index of the radical into the exponent. 4 into 20 goes 5 times. All right, now 39 on, we have coefficients and exponents. We're going to treat them differently because they do represent different things. The exponent represents the number of factors of y, while 100 represents an actual number, 100. So if we want to, we can divide this into two factors here. The square root of 100 times the square root of y to the 100th. The square root of 100 is 10. The square root of y to the 100th is y to the 50th power, because the index of the radical, which is 2, divides evenly into 100, goes 50 times. In number 40, this is the cube root of 27 times the cube root of c to the 27th power. Cube root of 27 is 3, and when we are simplifying an exponential expression, the index of the radical divides evenly into this exponent. 3 into 27 goes 9 times, so c to the 9th power. So we have a final answer of 3c to the 9th power. In 41, this is the 4th root of 16 times the 4th root of w to the 16th power. The 4th root of 16 is 2, and the 4th root of w to the 16th power is w to the 4th power. Again, the index of the radical divides into that exponent. 4 into 16 goes 4 times. All right, now we have some cases here where our index may not divide evenly into that exponent. So I'm going to use that same strategy. Square root of 9 times square root of x to the 9th. Square root of 9 is 3, and 2 divides into 9 4 times, so that gives us an x to the 4th, but we have 1 left over, so that 1 leftover factor is going to go inside the radical. Now, if you want to, you can also think of this as the square root of x to the 8th times the square root of x, since x to the 8th times x is x to the 9th, and the square root of x to the 8th gives us the x to the 4th, and then we have that leftover factor of the square root of x. In 43, this is the cube root of 32, which we can simplify by factoring out that perfect cube factor. That's the 3rd root of 8 times the 3rd root of 4 times the 3rd root of u to the 32nd power. 3rd root of 8 is 2, and then we have this other 3rd root that doesn't simplify, and then the 3rd root of 32. Well, 3 goes into 32 10 times, so we have a u to the 10th, with 2 leftovers, so that gives us a 4th root of u squared as a radical factor. So now just rearranging so that we have all our factors on the outside. On the left here, that's 2u to the 10th times the 3rd root of 4u squared. In 44, 4th root of 7, k to the 7th. So 4th root of 7 times 4th root of k to the 7th power. 4th root of 7 does not simplify. And if we think about the 4th root of k to the 7th, we can divide that index 4 into the exponent here. And 4 goes into 7 1 time. So we have a k to the 1. And we have 3 leftovers this time. So that's going to put a k to the 3rd on the inside of the radical. And so let's bring all of our outside factors to the left, and then multiply back together all the inside factors for the radical. And that's a 4th root, not a 3rd root, excuse me there. So that's k times the 4th root of 7 k to the 3rd power. In 44, we have the 3rd root of negative 24x to the 8th. So 3rd root of negative 8, because we want to get that negative outside the radical, so I'm taking my perfect cube factor and making it negative here, and then times the third root of 3, and then times the third root of x raised to the 8th power. Third root of negative 8 is negative 2, so we have negative 2 times the third root of 3, and then to simplify third root of x to the 8th, 3 goes into 8 twice, with 2 leftovers, so we have 3 third root of x to the 2nd left over. Let's move all of our non-radical factors to the left and then combine the rest of them so they're in a single radical. So we have negative 2x squared times the third root of 3x squared. In 45, the square root of 25a to the 2nd b to the 16th. So square root of 25 times the square root of a squared times the square root of b to the 16th. Square root of 25 is 5. The square root of a squared, again the index of the radical, which is 2, divides into 2 one time, so a to the 1 power. And then again with the b to the 16th, the index of the radical 2 divides into 16 8 times, so we have a b to the 8th power. In 47, fifth root of negative 32. That's an integer value, so we're not going to have to do much with that. Times the fifth root of x to the 15th, times the fifth root of y to the 5th. Fifth root of negative 32 is negative 2. For simplifying exponential expressions, divide the index of the radical, which is 5, into 15, and we get x to the 3rd power. Similar for the third radical here, 5 divides evenly into 5 one time, so that leaves us with a y to the 1 power. In 48, we can distribute the square root to both multiplication and division, so square root of 5 times the square root of x squared over the square root of 16 times the square root of y squared. So on the top, the square root of 5 doesn't simplify, but the square root of x squared is x, so we have x times the square root of 5, and downstairs we have 4 times y. In 49, third root of a to the 21st over 64b cubed is the third root of a to the 21st over the third root of 64 times the third root of b to the 3rd power. For variable expressions with exponents, divide the index into the exponent. 3 into 21 goes 7 times, so the numerator is a to the 7th. Downstairs, the third root of 64 is 4, and the third root of b to the 3rd is just b. In 50, we're going to distribute our fourth root. And in the numerator, the fourth root of x cubed does not simplify because 4 doesn't divide evenly, doesn't divide into 3. In other words, it goes 0 times, so we don't have anything that we can bring to the outside of the radical in the numerator. So we have the fourth root of x to the 3rd, and the fourth root of 16 is 2, so final answer is fourth root of x to the 3rd divided by 2. In 51, we can distribute the square root to all factors multiplied or divided. Square root of a squared is a, and square root of b doesn't simplify. Downstairs, square root of 100 is 10. In 52, the easiest way to proceed here is to try to factor out a square root of xy. So I'm going to factor out square root of xy, and the leftover factor in the numerator is square root of x to the 6th, y to the 2nd power. And downstairs we have a square root of x times y, and we can cancel those common factors, and now we just have the square root of x to the 6th, y to the 2nd. Now remember, when we are simplifying exponential expressions, you divide the index of the radical into the exponent. The index of the radical is 2 for a square root, so 2 into 6 goes 3 times, so our new exponent is 3 when the x comes outside the radical, and then y to the first power, because 2 divided by 2 is 2. In 53, we're going to use that factoring idea here. So I'm going to see if I can factor out the cube root of 2 times m. And if we factor out the cube root of 2 times m, that leaves us with the cube root of 27m to the 6th in the numerator. Downstairs we still have that cube root of 2 times m factor. Canceling those common factors or dividing those out, that gives us a quotient of 1. We have 5 times, and the cube root of 27 is 3. Cube root of m to the 6th is m to the 2nd, because when dealing with exponential expressions, we divide that index into the exponent. 3 goes into 6 2 times. So final result is 15m squared. All right. In 54 through 62, we are asked to simplify completely, but this time we're asked to assume that variables are unrestricted, therefore can be negative. What that means is we're going to have to consider the use of absolute value on variable expressions when necessary. All right, now 54, our final answer should not have an absolute value in it, and that's because this is a numeric expression. So we could simplify an absolute value even if we use one. This is the square root of -4 squared. And so if you want to just follow our order of operations, that's the square root of 16, which is +4. However, we could have gotten there by saying the square root undoes the square, but in doing so we have to take the absolute value of the number because it's an even root. All right, in 55, we have the cube root of a cube. They actually just undo one another. And if you, no absolute value should be used here. If you want to just follow order of operations, that's the cube root of -8, because -2 cubed is -8, and that gives us a -2 result. So either way. Now in 56, I'm hoping we don't have to square that -37. Whatever result that gives us, when I take the square root, it's going to undo the square, but it is going to give us a positive result since it's an even root. All right, in 57, the square root of 9 times the square root of x squared. The square root of 9 is 3. The square root of x squared is the absolute value of x. In number 58, cube root of 8 times the cube root of u cubed. Cube root of 8 is 2. The cube root of u cubed is u. No absolute value should be used here because the cube root of a negative number is another negative number. All right, in 59, even root. So we are going to use absolute value here. The fourth root of 16 is 2. The fourth root of c to the fourth is the absolute value of c. In 60, we have the square root of 49 times the square root of w plus 5 squared. Square root of 49 is 7, and the square root of w plus 5 squared is the absolute value of w plus 5 because this is an even root, so square roots undo squaring, but in doing so produce a positive result. Since w is a variable, we don't know what the sign of w plus 5 is, so we have to take its absolute value in order to ensure that the result is non-negative. All right, in 61, the cube root of k minus 1 cubed is just k minus 1. Odd root of an odd power is the power and root undo one another, and we just get k minus 1. No absolute values there. In 62, we can factor x squared minus 14x plus 49 into x minus 7 times x minus 7, which is x minus 7 squared. And the square root of a square is the absolute value of that radicand, so the absolute value of x minus 7 is the final result.